new theory is rocking the foundations of modern physics, which is overturning old obsolete theories of the physics with elegant,
breathtaking, earth-shaking, and groundbreaking mathematics.
The laws of physics are rearing, an entire scientific community is witnessing a genesis of new physics on its way. A series of astonishing breakthroughs in theoretical physics have culminated in so-called theory of everything, the string theory.
With the new string theory now, we could provide a comprehensive mathematical framework for all known physical phenomena, from the motion of galaxies to dynamics of a nucleus. And finally, unification of all known forces gets materialized on the shoulders of the theory. To bring things down to earth, compare this with quoting the mind of God. The string theory in most exalted way would possibly empower us to be gods ourselves. To help you better appreciate the excitement that string theory is generating among physicists, I would take a moment to describe all known fundamental forces. Force is something that could potentially pull or push something. Electricity is a force because it makes our hair stand on our head, and magnets do repel or attract other magnets. Physicists discovered that all known forces could be described as an interaction of only four fundamental forces. They are vis-a-vis, gravity, electromagnetism, strong nuclear force, and weak nuclear force.
Well, let me start things with gravity, the force that was laid undiscovered for thousands of years.
Gravity is an attractive force that binds us to Earth and keeps Moon on orbit, so on and so forth. This is most dominant force in the universe and was first forced to be split after the Big Bang. It extends trillions upon trillions of miles to the farthest star. In fact, the range of gravity is infinite. In 1600s, people thought that there were two distinct types of laws that rules heavens and laws governing mortals on earth. Laws of heavens were thought be different from the laws of mortals for perfect harmony. When Isaac Newton was 23 years old, he was sent from Oxford University because of a plague epidemic that was sweeping every mortal to grave. And on one fine day, an apple fell from an apple tree, which defenestrated Newton in the thought experiment. He sought out to ask himself a revolutionary question: if an apple falls, why not the moon falls toward Earth? These thoughts so worried him that he postulated that every body in the universe attracts every other body with a force proportional to the product of their masses, but varies inversely to the square of distance joining the centers. Perhaps Newton thought that moon is continually falling toward the Earth but remains hooked to its orbit because its velocity matches the receding curvature of Earth. This was the first unification in the history of sciences, uniting the laws of heavens with Earth. Electromagnetism is a force as a result of interaction of charged particles. It confers stability to atoms. Electrons orbit around nucleus as to counteract electrostatic force of attraction towards nucleus, so as planets orbit sun so as to prevent straight line path. Since M force determines the structure of orbital occupied by electrons, it governs all of laws of chemistry.
Early induction into the mysteries of magnetic effects of electric current and electromagnetic induction made it clear that magnetism and electric force were no more than two faces of the same coin, electromagnetism.
With Maxwell's equations, it became clear that magnetic field and electric field oscillate orthogonally and propagate through space without the possible requirement of ether. On the Earth, M force is strong enough to outpower gravity. A cone could attract snippets of paper by counteracting the gravitation force of this whole Earth. In macroscopic domains, the role played by M force is very evident. Friction, elasticity, and normal force are all different manifestations of M force. The range of M force is infinity and pervades all space.
Perhaps light is most common form of M force.
In a quantum level, these forces are mediated by virtual photons. Virtual photons are virtual particles.
The existence of virtual particles cannot be determined directly, but their effects can be Casimir effect, which pop out of blue
and survive for really short intervals of time. These are manifestations of energy-time uncertainty of quantum systems. But the probability laws of quantum mechanics are such that virtual particles, not real particles, can exist
if their energy times time is less than h4 pi.
This essentially means that nature allows fleeting particles to exist as long as it's for a really short time. And since energy and mass are equivalent, nature creates particles with mass by borrowing energy from the vacuum. but for a really short time so that it gets destroyed before it can be detected. They are really just excitations of the underlying quantum fields, but appear only as forces, not as detectable particles. So now if you digest that, the next question is, how does an exchange of these virtual particles result in a force? There are two ways to look at this. When two magnets attract or repel each other, it is due to an exchange of virtual photons. Exchange of virtual photons is not necessarily limited to magnets only. When two electrons come too close together, they would experience a force of repulsion as a result of exchange of virtual particles.
Here is a simple analogy.
Imagine two people on a boat throwing basketballs at each other.
As the two throw the balls away from each other, there is a transfer of momentum that occurs. This momentum transfer moves the boats apart. The more this happens, the further apart they go. This is analogous to the way that virtual photons transfer momentum from one charged particle to another, resulting in a repulsion of like charges.
If I'm right, you would be pondering about mechanism by which exchange of particles result in an attractive force.
Well, it happens through the exchange of negative momentum. If it is not in force, then we would crumble to pieces on our own weight. Strong nuclear force. Strong nuclear force seems to bind protons and neutrons together in atomic nuclei.
It is very evident that without such force, stability of the nucleus would remain uncertain. According to Coulomb's law, the two protons in a helium atom experience a force equal to about 20 pounds.
For something as small as atoms, this is a huge force.
They should repel each other and fly apart instantly. Therefore, a new basis but a very strong force must be invoked.
The strong force is the strongest of all forces, which are about 100 times as strong as M-force.
Roughly speaking, only few hundred elements maintain a delicate balance between attractive strong force and repulsive electrostatic force.
That is why only the first 82 elements are stable, with the exception of technetium and promethium.
Since the effective range of strong force is about the diameter of a proton,
the effects of strong force in day-to-day life remain ephemeral.
But once the energy lurked behind strong force is unleashed, the consequences are catastrophic.
In an atomic bomb, a uranium atom is bombarded with a fast-moving neutron. Enormous energy is released in a nuclear detonation.
That is the reason why atomic bombs stand out from chemical explosives, for chemical reactions are governed by EM forces, which is only 1% as strong force.
Strong forces are mediated by gluons.
But these forces act over very short distances, the diameter of a proton. Gluons are massless as photons, but their range is short-ranged. The math does not seem correct. This presents a conundrum.
The answer to this question can be unlocked only by knowing the principles of quantum chromodynamics, or QCD.
Recent developments reveal that protons and neutrons are made up of even elementary particles called quarks. Gluons bind these quarks together. The reason why M-force has infinite range lies in its charge. Photons are electrically neutral, that is, they do not interact with each other.
On the other hand, gluons are charged, but not in the way you think.
They possess what known to be color charges.
Since these mediators carry color charges, they end up interacting with themselves as much as interacting with quarks, forming a rubber tube or flux tube, limiting their range.
To reiterate the conservation of charge in any isolated system, scientists have come up with three color charges: red,
green, and blue. All these colors will combine to give white color.
Remember that color charges are merely a metaphor for the properties of gluons. It turns out that quarks also have these color charges, and therefore gluons end up interacting with quarks.
These color charges could also be thought of as a direct consequence of Pauli's exclusion principle. It states that no two fermions, quarks or fermions, can occupy the same quantum state in the same quantum system. With the proposal of color charges, the mathematics of quarks could now remain consistent with Pauli's exclusion principle. Strong force is rather unique because electromagnetism and gravity get weaker as objects get farther apart, but the force between two quarks, however, actually gets stronger as they get further apart. It works like a rubber band. If you try to pull two quarks apart, the force between them gets very strong. When they are close together, the force is weak. This tends to pull a quark back into the proton or neutron. However, if you knock a quark very far away from the neutron or proton, the energy becomes so large that the rubber band-like force created by gluons breaks, and the energy release creates a new quark-anti-quark pair, and one quark is pulled back into the proton. The newly created quark-antiquark pair is called a meson. The gluons are involved only indirectly in the process of creating the mesons. And since mesons do have mass, if you do the math, the range of the force keeping neutrons and protons glued together is very short, about the diameter of a proton. The God equation. Much of our life is impossible without these fundamental forces.
The challenge was to write a mathematical equation whose elegance would encompass all of physics.
The new theory states that all these forces are manifestations of a single force. The leading candidate for this unified field theory is string theory. The string theory assumes that the ultimate building block of matter is made up of strings. These vibrating strings could possibly are place point particles and explain the rich diversity of matter around us.
Fundamental forces in nature are found out to be different modes of vibrating strings.
The gravitational interaction is found out to be the lowest vibratory mode of a circular loop. String theory allows us to establish an equation not more than an inch long and allows us to predict the mind of God.
M-theory.
Current versions of string theory require 10 dimensions total, while an even more hypothetical upper string theory known as
M-theory requires 11 dimensions.
But when we look around the universe, we only ever see the usual 3 spatial dimensions plus the dimension of time. In the next blog, we would explore more about supersymmetry and hyperspace. If you have found the video interesting, consider subscribing to the channel. Thank you.